Welcome to Dear SQL DBA. I'm Kendra Little. Dear SQL DBA is a podcast and YouTube show where I answer questions from database administrators and sometimes from people who work with database administrators. Today's question is from a SQL Server DBA who is assessing storage performance on their SQL Server and wants some help working with their storage admin. Here's the question. Dear SQL DBA, what do you say to a SAN admin when you think that the billion-dollar SAN may be the bottleneck and you just want to look into it? What are the technical things I need to say to make them believe that there might be something to my questions? Sincerely, outside the big SAN box. Well, this question is actually near and dear to my heart because I have been called in a lot of times as a SQL Server consultant with the question, is the storage what's slowing our SQL Server down? And if it is the storage, what do we do? Because we've spent a lot of money on this storage. And figuring out, is it the storage, is pretty mystifying to a lot of SQL Server folks because they don't know where to look. And there are a lot of places you could look. SQL Server gives out tons of different metrics. And the good news is there's actually pretty straightforward places that you should look in a pretty clear, to me, order that you should look at them in. So it's actually not rocket science. It's totally doable. So you need to know where to look, and you need to, interpreting the data, you got to kind of get used to interpreting the data and understanding how to do it, but it's not that bad. It's not as mystical as you might think. So your mission in terms of framing this conversation is really what you want to do is look at the SQL Server and get metrics to get evidence of when is disk latency impacting performance and how much is disk latency hurting performance. You want to do your homework looking at the SQL Server and maybe Windows if you have to, but really that's really just a political thing if you need that to kind of bridge the gap between sort of SQL Server as a black box and the SAN as a black box. But you can get the same metrics from the SQL Server. You want to get your homework from there of what the latency is and figure out, the first thing you're going to figure out is just, is it sort of emergency levels of slow? If it is emergency levels of slow, you don't want to, write a dissertation on, you want to just address that right away and say, hey, we've got messages coming out of the SQL Server that this latency is at emergency levels. We need a team to help, triage what's going on here right away. If it isn't emergency slow, do a more, thoughtful investigation and investigate, okay, if we do have storage latency that's slowing us down, is there a way we can alleviate this with a method that's cheaper than just speeding up the storage, or do we really have to? Know what your options are before you kind of go in with that, because you want to present a range of options to people. Because even though a lot of money has been spent on this storage, does that necessarily mean you should spend, that to speed it up? Usually, speeding it up isn't free. And do your due diligence, right? So if you if you don't have other options to speed it up, then you really want to know, okay, for the latencies that we're seeing, here are specifically the places that are most impacted and where it will be most helpful to reduce that latency. You want to then take a summary of what you have and, make all of the keep notes on it as you go through and make all of the data that you've gathered in your analysis, make all of it available to the storage admins. But, just like the storage is a big black box to the DBA, like they aren't going to want to read all of the detail of your notes. They may kind of want to glance at it. It's a courtesy to say, yeah, here's all the stuff we've looked at and the data we've gathered. But write up a short summary of high level, yeah, here's the latencies, here's what it impacts, and here's where I would really like your help reducing this latency on the SQL Server. I really like the way that this question was framed in terms of saying, okay, well, how can I make working with the storage admin more successful? There's already some concern on saying, I want to do this in a way where I get taken seriously. And this can be kind of a touchy conversation at times. I have been talking so far. You've probably heard me say disk latency and storage latency a lot already. And I would really, when I look at this, I focus on that. Here are the latencies that we're seeing and how much it is slowing down our workload. And you'll want to dig specifically into what type of latency it is as well. And I always want to talk about, okay, we're looking at it at the SQL Server level and the storage latency it's seeing, because that's what we have the information about. A SAN is a large, complicated thing, and saying the SAN is slow, that seems like a really simple thing for a database administrator to say. That doesn't seem like a big deal to us, but that's a lot like someone else, either, imagine a developer or the SAN admin just saying, well, the SQL Server is really dumb, it can't handle it. It's just kind of like calling someone's baby ugly, right? Like, it's a really general statement, and it just makes the person saying it seem kind of not really informed, and, they're just sort of pointing fingers. So that's why I would just be really specific about what we're talking about is storage latency that we see from the SQL Server. We don't know if the problem is a cable connected directly to the SQL Server or something much deeper in the SAN. It could be a whole lot of different things. What the SQL Server can tell us is, how much am I waiting on storage and how much is it slowing me down? And that's really the important thing that we can get out of it, because we can see exactly what is slow and how it is slow. So let's dig into how we can see that. The very first thing that I like to do for this kind of thing is just check, is the SQL Server saying, this is way slower than it should be? This is like basically an emergency, it's so slow. For this check, you want to look in the SQL Server error log, and what you're looking for is these 15-second warnings. If you look in the SQL Server error log, you can use a little filter on the log and say, I want to see messages in the log that have this text in it. And you can check off all the little SQL Server error logs that your SQL Server has. I actually like to configure my SQL Server to keep 99 logs, and then I like to set up a SQL Server agent job that rolls over the log every night so that it's really easy, to have like 99 days worth of logs. Personally, but you want to filter the messages for the term longer than 15 seconds, right? You could just filter for 15 seconds. If you do that, you may just get, hey, this backup finished in 15 seconds. You just have to manually look through them. That's fine too. What you're looking for is a message that says, SQL Server has encountered some number of occurrences of I/O requests taking longer than 15 seconds to complete on file, blah, 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 in database, blah. This message literally means I issued an I/O request or more, right? It tells you the number, and the number may be 10,000, the number may be 1. This many I/O requests were issued, and I have not gotten a response back from the storage in 1001, 1002, all the way up to 15 seconds. So it's not like, if you see that it's like 11,000 requests, it's not a total of 15 seconds, like cumulative. It is literally, it has been 15 full seconds for this number of requests, like just like you would see on your watch, right? Now imagine a user, right, who clicked a button that tried to insert a record, and the transaction log was waiting 15 seconds. Now you can tell if it was the transaction log because it will tell you the name of the file that had the latency. And the way this works is SQL Server, if it gets to a point where I/O is this slow and something passes the 15-second mark, it will stop and count, okay, how many of these requests do I have? And then put this message in your error log. And what files are they on, right? So you might see at the same timestamp, you might see this message for 4 or 10 or a lot of different files, or you might see it for 1 because it checks it. It'll give you a message for every single file. It is a relatively expensive operation to check for all of these I/O requests, though, so it doesn't like repeat this message every 15 seconds. It will wait 5 minutes before these messages occur. So if you see a bunch of these and the messages are 5 minutes apart, the storage latency issue may have been continuous through the 5 minutes. It's simply not going to spew the message every 15 seconds. I do look at the entire message. If you see, because you can get some information and make some, kind of deductions from it logically. If I see that this message says I issued 2 I/O requests and I haven't heard back in 15 seconds, well, I kind of know, well, my SQL Server didn't overwhelm the SAN with its 2 I/O requests, right? I can see a little bit of information about, okay, well, how active was I even making storage requests at the time? And that does give you a piece of information about a little bit about what was happening on the SQL Server at the time it experienced the messages. If you see these 15-second storage latency messages, this is severe latency, and this is something I would address right away. I wouldn't spend time you are going to dig deeper, but I would engage the storage admin team right away and share the times that it happened with them, the number of occurrences, and check on things like, was any maintenance happening on the SAN at that time? Do we know of a reason why these things would happen? If you see specific patterns in the times, you want to get together, because these messages should not be happening in your SQL Server, period. You should be able to scan large tables and do I/O requests, and you may get some latency, but 15 seconds of latency with, nothing coming back is really, that's just, things are not working, and you're at the point where the SQL Server, it's so slow that it's putting messages in the error log to say, hey, this is an emergency. This is a problem you should address. So you want to know, okay, if this is happening, how many things are using the storage at this time? How active was it? Was there maintenance happening? And what's going on? I have had the causes from this error. I have had times where the cause of this error was a faulty cable, right? Where there was a faulty component. I've had times where it was being caused by maintenance. I've also had times where we've looked at this and we brought it up to the storage team, like, hey, we've got, in this case, the case I'm thinking of, it was TempDB. Hey, we've got this TempDB file. It's frequently getting these severe storage latency requests. And, the storage admin is a great team. They were like, well, that's funny because we put that on the faster SSD. And you can almost hear in their voice that they're looking at the screen. And they're like, oh no, we didn't do what we intended to with that file. That's not using the fast storage, right? And then they scheduled some maintenance because managing storage is complicated, and everything worked well. Nobody blamed anybody, but that is the kind of thing where this is an unusual an error, hence the error log. So that's the first thing. Check the error log for the 15-second latencies. Other stuff. What if it's not emergency slow? How do I check if it's just garden variety slow? It's working, but maybe not well enough. How do I look for that? Well, this is where the dynamic view sys.dmio virtual file stats is really going to be your best friend. This is a fantastic dynamic management view because what it reports about is how often am I doing physical storage access, like the number of storage requests we're making per file in each database. How much I/O are we doing? You can actually figure out how many megs and how many gigs a second you are pushing and pulling from storage. And what is the latency of the requests, which is awesome because if I'm just talking about like all the queries that run against my SQL Server, not every query needs to use storage. If I'm running just a select query against my SQL Server, and the data that I want is already in memory on the SQL Server, it's not going to go do a read against the data file if it doesn't have to, right? So we don't always have to use storage. What we're wondering about with the SAN is how often do we have to go to storage, and how slow is it? And sys.dmio virtual file stats tells us exactly that. There's a bunch of free queries out there and tools that you can use to read this, or you can write your own scripts. What you really want to know before you start sampling it too much is you can just query, okay, well, since the SQL Server has started up, how many reads have I done? How many writes have I done? How many gigs, and what's my latency? But that information since startup isn't really all that useful because it contains all of the physical reads and writes. So when you're running a full backup, SQL Server has to go read all the data from disk, right? When you're doing log backups, we need to read from other parts. When you do checkDB to check for corruption, it's got to go do a bunch of physical reads. When you do things like index maintenance, you're doing a bunch of reads and writes. And some of these things that you're doing are at times when you don't probably, it's different for different databases, but probably at times when you don't care as much about performance, which is why you're doing the maintenance during that window, right? So if I just look at my latencies since startup, I'm averaging in my physical storage latencies. I'm averaging in all these maintenance times as well as possibly times when the system is just idle, right? And I'm averaging it out over time. It's a data point. I do look at what are my average latencies since startup and how much am I reading and writing from different files. But I just know that that data is kind of diluted out by all of this maintenance and times that aren't performance critical. So what I really want to know is, especially during times when performance is slow, like during the workday, over a, say, 5-minute period, how many physical reads did I do? How many physical writes did I do from different files? How much data was read and written to? And what was the latency? So what you do, or what your monitoring tool does, because sys.dmio virtual file stats is a critical DMV that most monitoring tools do already pull. So if you already have a monitoring tool looking at the system, it's harvesting this data for you most likely. What you really want to know is during that sample, what, were these amounts? So if you were writing your own, which you can choose to do if you don't grab a free one on the internet or a monitoring tool, you would have it write the information to a table every 5 minutes, and then you would write a script to do a diff between two different samples and say, okay, well, how much? What was the latency? And then you can analyze it, because what you really want to know is, how many, did I do any physical reads? I've actually had times where people brought me in and are like, we think it might be the storage. And when we look at it, when performance is slow, we're actually doing very, very minimal reads and writes to the storage, and most of the activity is being handled out of memory. The storage has almost nothing to do with it. Which, let me just say, this dynamic management view is incredibly powerful for being able to point out, do you even need to care about the storage? Because if you can narrow that down and see the case, that points you to, okay, I got to look at query performance. I got to look at SQL Server weights, because the problem is not between me and the storage in that case. It might be, though, that I look at that 5-minute sample when things are slow and I say, hey, look, so I'm not actually doing many reads from the SQL Server data files. There's a really low number there. And you can throw out really small samples. Like if you see that there were 2 physical reads in 5 minutes, even if those have, like a 200 or 500 millisecond latency on it, this is literally 2 individual IO requests. That's a very small sample size. It's probably not a big deal. So the number and the amount of data that you're pulling it back does matter. But you might see like, whoa, we actually have a bunch of significant latencies. We're pulling back, we did 2 gigs of reads and writes against TempDB, and we have a notable latency against TempDB. We are actually, using that more. Or you might see that it's the log file. What you really want to know is look at which files it is, which type of read and write are it, And are your latencies above acceptable thresholds? Right? So, wait, what? Latency is acceptable? Well, if we're going from the SQL Server to the storage and back, it is not as fast as accessing memory, right? Like, so going to the storage, there is going to be some latency. Microsoft has published some latency numbers as to what is acceptable for SQL Server. And here's what they give. They say, and this is from their white paper, this was back from 2008. The white paper is named Analyzing I/O Characteristics and Sizing Storage Systems for SQL Server Database Applications. This is from the Microsoft Customer Advisory Team. They say in there that for data files, they really want latency to be below 20 milliseconds for OLTP and below 30 milliseconds for decision support or decision support or data warehouses. For transaction log files, they say the latency should be below 5 milliseconds. Now, these are actually pretty aggressive targets, which is funny because this white paper is from 2008, right? Like it's much later, and I'm like, these are pretty aggressive targets. Like, it would be awesome if everyone's storage was this fast, but if you're seeing 50 millisecond latency on writes to your data file, that probably doesn't mean that your SQL Server's on fire. So you got to kind of take these with a little bit of a grain of thought, because one point about SQL Server is this. When you write data to a SQL Server database, let's say, you click a button and a row gets inserted, that insert doesn't get written directly to your data files. That would be kind of slow. What SQL Server does instead is that write will go into memory, and then writes go to the transaction log file. SQL Server uses a write-ahead log. So the speed of writes to that transaction log file is really critical. And once your transaction is committed, it can tell the application, hey, I got your insert, everything's good. It doesn't have to also wait for it to write to the data file. So if you're seeing, like even 100 millisecond latency on writes to the data file, that doesn't mean that a user is sitting there just waiting for 100 milliseconds for every single write that happens. Write speed is more critical to the transaction log file, and that's why they gave it the lower threshold too. So when it comes to writes, you particularly care about transaction log performance. You may also care a lot about TempDB performance, depending on what your workload is. Some people use a lot of TempDB. Some people use hardly any TempDB, depending on kind of what your code's actually doing. So those are Microsoft's latency thresholds. It's good for you as a DBA that they publish pretty aggressive ones, right? Because, you can say, here's where we are. Here's these thresholds of where Microsoft said was acceptable way back in SQL Server 2008, right? So that actually works out pretty well for you. Some other things to think about. When you look at DMIO virtual file stats, think about, okay, well, does it look like, are we suffering from read latency against data files? And if read latency against data files is high, how much memory have we given the SQL Server? And is it possible that we could add that? Like if we have a small amount of memory allocated to the SQL Server compared to the amount of data that we're reading from disk, SQL Server loves to cache data that it reads again and again in memory so that it doesn't have to make that long trip to disk. And if you can give the SQL Server more memory, depending on how much memory is available and your version and edition of SQL Server, that can be sometimes much cheaper than speeding up the storage, because although we do have to pay for memory, it is a lot cheaper to pay for memory than for speeding up a SAN. So whenever I'm looking at latencies, if I see read latency from data files, I want to think about my options and think about potentially adding memory as a cheaper option to speeding up the storage. If I'm seeing heavy write latency to a transaction log, if I'm seeing, and I have seen sometimes, Like what I would consider an extreme example is seconds of write latency on a transaction log. This is the one where Microsoft wanted it to be 5 millisecond or less latency, right? If I'm seeing extreme latency to a transaction log, that is really bad news, and it very much concerns me. And I want to say, okay, what do we have writing to the transaction log? Like, can I see, actually, just from a brief look at the SQL Server, maybe using a tool like SP Who is Active, or possibly looking at some of the index dynamic management views to see which tables have the more writes. Like, what is actually being written in there? One thing I am often really suspicious of when I see a very high volume of writes is that the database has something like user session state combined with other tables in there. There are certain types of applications that can be really, really chatty on writes, like session state. And I don't really want to combine those in a single database, which only has one transaction log, no matter how many files I give it. I don't really want all of those committing in the same transaction log. I would much rather session state lived off in its own database with its own transaction log for it to be super duper chatty at. Just because in terms of being able to control which disk it uses and control its latency, I kind of want it to be, in its own little boat so I can control it better. So I kind of want to know when I see high latency against a transaction log, what am I doing with the writes? But then I also do want to talk to the storage folks about how can, we are seeing latency against this log file. The log files are our most critical resource of the database for performance in terms of write speed, and we also need to be able to back them up quickly for recovery. It's critical to be able to speed that up. The kind of bad news if you do see latency against a transaction log file is speeding up storage is expensive. Changing application code patterns also tends to be fairly expensive as well, right? It's not like a quick fix. It is possible that this could be one of those situations of, we thought that transaction log it's not on the right storage for the transaction logs. We had that against a different pool of disks than we thought. Sometimes that happens with those too. Another thing I look at, just as sort of a cover your butt or cover your developer's butt, if I am seeing a lot of storage latency or even a moderate amount of storage latency, I often, if I'm able to, want to do a sanity check on indexes in the database. Now, there are absolutely times where you should be able to scan large amounts of data quickly, right? Like if you have spent $1 billion on your SAN, it may be because you can't index every query. That's valid. But what I am saying is, because speeding up storage is expensive, it is worth checking just to do a due diligence check and say, have we created some of the basic indexes for our most frequent queries just so if we don't really need to make all those trips to storage, we don't just sort of squander our storage, right? Indexes in SQL Server databases can be a way that you can optimize and reduce the amount of data that SQL Server needs to read. And if we do have, let's say in an extreme example, I have found cases where the SQL Server is just repeatedly scanning large tables over and over and over again. There's a really simple index that we can give it that means that instead of doing this big scan, it simply, bink, looks up one page or, reads a few pages every single time and does a lot less work. This change with the index means suddenly the data that it needs can fit into memory. All of a sudden, we are asking a lot less of the storage and our performance is better. Arguably, that if you are in that situation, it's worth checking to say, hey, can we solve it that way? Just because it is better and cheaper for your business and for your customers to do that than to try to speed up the storage. Now, it's just a subset of cases. And if you've never done an indexing health check and you're more of a system administrator type, this is something that you want to say, hey, do we have any developers on staff who could help me with this? You don't want to have to teach yourself index tuning just for the point of checking off this box. But when you do have the resources to do it, doing a quick check of just, is SQL Server saying, hey, I could dramatically improve my workload by adding an index? Because sometimes I have found cases where that's absolutely the solution, because the index just means it doesn't even have to use the storage as much, right? So worth doing is due diligence. At times, and it is fairly rarely, at times I have needed to gather performance counters from Windows. There are some performance counters in Windows that essentially do the same thing or report essentially the same information as the sys.dm IO virtual file stats dynamic management views. There's physical disk counters for Windows where you can look at what was the latency for these drives. The counter names are average disk sec/read and average disk sec/write. How much latency am I having for reads and for writes? Of course, it's not by database and data file, it is by drive. It's a physical disk counter, so it's by drive. The only time I really have had to look at these is when there was such a lack of trust between the storage team and the DBA team that really bringing in the Windows counters kind of helped, because the storage team was like, yeah, we kind of understand Windows. We don't really know what's up with that SQL Server thing. It's like witchcraft. And, the DBA team was like, we don't really understand the SAN team. That's like some sort of witchcraft. But looking at the Windows counters and saying, here's what the SQL Server shows. Here's what Windows shows, because it was sort of, because it's an operating system level tool. It was kind of like, oh, okay, well, yeah. Now, why are you seeing that number, right? It kind of helped to bridge the gap. So there's some political situations where taking the extra step would be worth it. Oftentimes you don't have to, because you can just say, look, the SQL Server is saying it sees these latencies, and we can go on that. So quick recap of what we've talked about, of sort of bringing up the subject in a way that is collaborative. You want to talk about measured storage latency and the impact on the SQL Server. I really like to stick to data points of, this is the latency that we are seeing, just to keep it away from anything personal and to keep people from being defensive. This is our data about the latency we have specifically for these files. Can you help me figure out, where is this latency coming from? It's outside the SQL Server. It's over there. But I need help navigating over there, because every SAN is different these days, and there's a myriad of places between the SQL Server and the disks that things can be slow. I always look for emergency slow first. Those are those 15-second I/O warnings in the SQL Server error log. And I really want to triage these as, the SQL Server is warning in the error log that this is an emergency level of slow. Sys.dm IO virtual file stats is the dynamic management view that you want to sample during periods when things are slow, so that you can see how much you are accessing storage, what the latencies are, and what files are, and you can analyze that information against the acceptable latencies that Microsoft has published to see, okay, when we're using the storage a significant amount, not just a couple little accesses, but we're actually using the storage, how far are we from where Microsoft says we should be? And exactly where is it making us slow? Always think about, is there a way that memory or indexes could solve this more cheaply? And if you absolutely have to, bring in those Windows counters to kind of help bridge the gap. Sometimes you may get to the point where you're like, I have this latency, it's notable, it's definitely worth tackling, and you might get into a situation where your storage admin is like, well, okay, I don't know what to do. You've got this latency, I don't know what to do. Well, at this point, your storage vendor is probably the best one to talk to help triage, but that is going to come at a cost. Depending on what SAN you have, some of them do kind of publish manuals with some troubleshooting info, but we are getting kind of, it could be many, many different things. If you do have a recent SAN purchase, it is possible, like you can look at, okay, what was promised to us in terms of performance? What are we actually getting? You might be able to get some mileage out of the question based on, hey, can we bring this up as an issue and raise this as a difference? You might be able to say, hey, can we, at least as part of the investigation, set up a similar system that we can bang on? Do, of course, know that when we are talking about shared storage, if you are banging on and stressing a system that is sharing components with your production system, you can, of course, impact it. So you do want to be careful and make sure that when you're doing any kind of stress test, you know what else you might impact and are kind of prepared to monitor it very, very carefully in real time while that goes on. So thanks for joining me and discussing what happens when you are outside of the big sandbox. I'll see you again next week.